Good evening, sir, respected jury, and members of INSDAG. Myself, Mars Qureshi, along with my fellow team members, Atharva, Mustafa, and Manda, fellow team from Saboo Siddik, College of Engineering, is here to present our work. We were guided by Dr. Ganesh Kame. We thank INSDAG for organizing such an event during this pandemic situation, helping us learn and ameliorate our skills, allowing us to make good use of our time. I'm waiting for my friend to present the slide. So, baseline plan, you'll be seeing a ribbon at the top to keep a track of our presentation. From the next slide, we'll give an introduction about the project, its scope and stipulations, a concept, scheme, and its advantages. We'll be discussing the load considered and some design calculation of each element. Now, I'll start with the introduction. To bring to your notice, the main scope of this project was to provide the most economical solution of a modular quarantine center building with faster construction facility and all relevant design detail thereof to the client. As if INSDAG has appointed us as their RCC structural consultant. The 100 beds quarantine center with a surge capacity of 133 beds can be constructed with the proposed design. The report gives detailed structural scheme with detailed design and drawings, bill of quantity, and possible time of construction as per given parameter. Next. As you'll see, according to the scope, we have provided modular construction with easily available sections. No special sections have been provided. We have prepared drawings, BOQ construction schedule as well, with possible time of construction as 7 days. Next. The location was Jalpaiguri, West Bengal, and these are the material as stipulated by INSDAG that are to be used and the loads that we have to consider from the code provision. Next. The type of truss used is Northlight truss with a span of 35 meters. The overall dimension of the quarantine center is 35 by 50 meters. You can see a brief BOQ of the structure. The truss is triangular in slope. Next, having a rise of 4.375 meter at ridge from 7 meter eaves height. There are 8 bays of 6.25 meter each. The end bays are braced for stability. Bolted connection is provided. The girts and column are of ISHP 200. The truss member is made of angle sections. Footing. Hello? Hello, am I audible?
Yes, we can hear you. Please continue.
Yes. The footing is provided at 3 meters from the ground as stipulated. Next. This is the front elevation showing the 35 meter span and our truss. Eaves height is 7 meter. This is the side elevation with end base. We have provided bracing system. Now we'll move on to our next slide. Advantages of the modular quarantine center that we have provided. While designing the various units, a thoughtful attention is given toward efficient design and methods of various services to be provided at quarantine center. The quarantine center can be transported, assembled, dismantled, reassembled, and attached to modular accessories with ease due to its modular design. It can be completed in 7 days, and I'd like to show how the 7-day schedule is next. Day 1 activities: center line marking, leveling, excavation of foundation, PCC on rubble soling. Requirement would be around 21 laborers and foundation and bulldozers, excavators, survey instrument, and dewatering pump. On day 2, we can receive precasted footing with stem or casting footing with high early strength. We recommend that we should provide precasted footings as it would save a lot of time, and also the size is convenient and can be transported in 12-meter trailers that we have right now in transportation system. Equipment, we can hire 15-ton capacity hydraulic crane or a 25-ton capacity crane, but 15-ton would be more cheap, but 25-ton would be more efficient. And on day 3, after completion of footing work, the steel work can commence, and most of the connection should be done at shop, and the remaining connection can be done at site. as much as possible to save time and efforts and to reduce the labor at site, as we are executing a quarantine center. We don't want to have great strength of labor. Next, the day for erection work will continue. The flooring can be treated with PCC. The other related works can be started. On day 5, structural steel work should be completed by now, and the cladding and roofing work shall start. On day 6, all the work shall be completed by 6th day. Checking and handover formality should start soon. Day 7 is a free float that we have in hand. If at any cause, if there is any delay due to anything, we have a day in hand to get our work done. That is all by me. Now I'll hand over to Atharva for our next session.
Good afternoon, respected jury members. I am Atharva Rajesh Lokhande, and I'll be talking about the loading, analysis, and design section of our project. In our analysis, we have calculated the dead load, live load, and wind load according to IS codes 875 part 1, 2, 3 respectively. So according to the specification given by the INSDAG, as discussed by my fellow team member Maz, our location is Jalpaiguri, West Bengal. So the west basic wind speed there we have considered is 47 meter per second. We have also considered an extra dead load and increment of 16.5 for MEP and other utilities for future purpose. So as you can see on the screen, the dead load we considered self-weight plus purlins is 0.2 kilonewton per meter square, live load as 0.75 kilonewton per meter square, and the wind load which we calculated with the help of part 3 of 875 uh, with the help of the factors and the coefficients given was 8 can you thank you 879.02 Newton per meter square. Moving on, as given by the specifications given, we also designed for compression tension members. We have used STAD Pro software for our design purpose. We have also done a manual check for compression and tension carrying members. We have followed the design procedures as per IS 800. So as given in the photo there, the member used is 110 mm and the compressive load is 92.5 kilonewton. Next slide, please. So with the help of the IS code and the steel table, we found out the design load and it turned out to be safe for compression. For the columns as a compression member, the load on the columns was 175 kilonewton. Next slide, please. So the design load came out to be safe as 394.286 kilonewton. For tension member, we considered a member and the design strength due to yielding of cross section, rupture and block shear was found, and the lesser of all the values was 184.1 and hence considered to be safe. Moving on, design of joints. At the ridge point, we carried out the design of the joints and the bolts as given in the figure you can see. This is the footing design, which is below 3 meter ground level. And now I'll request Mustafa to talk about the BOQ.
Good evening, one and all, respected jury and my dear friends and everyone. So, coming on to the BOP part, the civil engineering standard method of measurement defines a bill of quantities as a list of items given brief identifying description and estimated quantities of the work comprised in a contract. The purpose of bills of quantities is as follows: is used for tendering, valuation of interim certificates, valuation of variation, ordering of materials, reference during the construction, quality and cost, construction planning and monitoring, subcontractor quotation, final accounts, and cost analysis for future use. Now, the primary function of the bills of quantities is to obtain competitive tenders. For this purpose, bills should be as standardized as possible in method of measurement, format, and layout. BOQ fully describe and accurately represents the work to be executed, including the obligations required of the contractor and to provide a uniform basis for the preparation of competitive tenders. So here is a BOQ of trust structure as shown where all the structural trees are mentioned and the quantity was found out to be 42.045 metric tons. So the BOQ of roofing, we have provided protected galvanized corrugated metal sheet of class A thickness 0.63 and the weight was found out to be 11.83 metric tons. Coming on to the purlins, we have used cold form section for purlins and the weight in metric tons was as follows: was 14.194 metric tons. The BOQ of footing, we have provided cleat angle and longitudinal reinforcement. The weight in metric ton was found out to be as shown, and the brief view of the structure is as follows. Now my friend Mars will conclude the following presentation.
As a conclusion, I'll bring to your notice that the whole structure is designed considering the requirement of modular construction. The scheme can be completed in a week's time, as explained in previous slide. Also, there is scope in drawing that consider extra loading for MEP, HVAC, or other accessories that we require in the near future. Bolted connection are used with no special sections. Thus, this scheme can be incorporated in many areas as a basic wind speed is 47 meter per second. And also the sections are easily available as we have already used ISA sections and ISHB only. And also the concrete grade is M25, can be made at site as well or in the shop. We have recommended precasted footings. The scheme will be best suited to the given stipulated condition, but it is agile and can be repurposed after the COVID-19. The material used are very common. The quarantine center so designed will prove its design life of 50 years with great efficiency and can be repurposed after the bad time. This will fully realize the capital invested. Next. As a concluding remarks, our project is a modular construction with a 7-day schedule, extra loading for utilities, and steel consumption of 2.23 kg per square feet. That is all about our project. I'd like to show you our references, and I'd like to thank INSDAG for giving us such a learning opportunity and making good use of our time. And also, I'd like to thank my college, MS Saboo Siddik, College of Engineering, for their constant support and motivation. Thank you.